Good evening. All right, there's a crowd out there, I think. You can see. Yeah. So I'm your moderator for this evening. I'm Jeff Bradshaw. I'm the bug guy for the Panhandle, and working at the Panhandle Research and Extension Center. And I'm really excited for our film and our speaker this evening. The way we'll do things is Wayne will come out. He has a presentation to present to you all, and it ties together the various points in the film. And then after his presentation, we've got I believe a short video to show as well, and then we'll roll the film. So before I ask Wayne to come out and begin, I have a short bio here. Dr. Wayne Woldt is Associate Professor and Extension Specialist at the University of Nebraska in the School of Natural Resources and the Department of Biological Systems Engineering. He is the Director of the Nebraska Unmanned Aircraft Innovation, Research, and Education Laboratory. And his areas of interest include agriculture, flight safety, and land mapping. His pilot ratings include private, glider, hot air balloon, and remote, with over 700 hours of total flight time. So he has a diversity of experiences, not just with unmanned aircraft, but also manned aircraft as well. So he's going to speak to us this evening about drones and aerial robots buzzing for agriculture. Please help me welcome Dr. Wayne Woldt.
Thank you, Jeff, and thank you to all of you for coming on out this evening, learning about these aerial robots and how we might benefit from them in agriculture. And also, thank you to all the workers and those that have gone into putting on this science on screen. I think that's a really neat concept. It's taking movies and kind of extracting or pulling out science out of the movies, the art side. You know, the movies are the art, science is the science. And it's just really a cool idea. So I've really enjoyed working with Jeff and Katie and Jeff and the Panhandle Research and Extension Center, Midwest Theater. It's just been great. So I want to thank you also for coordinating this and bringing something like this to the community. Well, let's go ahead and get started here on this topic of unmanned aircraft. Drones, another term. Aerial robots, another term. And I've kind of titled this Drones, Aerial Robots Buzzing for Agriculture. When they're flying, they are buzzing. So this evening, I'd just like to give a little bit of background on what we're doing. My focus will be on the research that we're doing at the University of Nebraska. But I'll also draw in some of the movie. But I'm not showing movie clips here because you'll see the movie after. But what I'll do is mention, okay, in the movie, they talk about this, or this is represented, and then I'll talk about what we're doing and kind of parallel to it. And also then some selected projects, because in the movie they do talk about how drones have been used for this, and they've been used for that, and they're used for this. Well, we're using them for certain things too, and I'll talk about some of the projects, and then I kind of want to visit a little bit about aviation safety, because that's really important. You know, at the end of the day, it's really important that we all go home and we don't have any problems that might occur, any accidents or anything like that. So a little bit of background. And I keep this slide in because things are changing. This slide, when I used to give presentations, it used to say, unmanned aircraft will be legal to fly. That's because they weren't legal to fly for commercial purposes until fairly recently, actually. They're expected to be a great benefit to agriculture. And this is interesting. If you think about the whole market for unmanned aircraft and the numbers, the market projections are huge. I've heard unmanned aircraft is referred to as the next internet. We don't really even know where they're going to go. There's so many potential applications. But for the most part, virtually all market research shows that agriculture is expected to be about 70% of that unmanned aircraft market. That's pretty amazing. Of all the work that's being done with drones and such, agriculture is expected to be the big part of that. The Federal Aviation Administration does regulate unmanned aircraft, and aerial view offers a strategic advantage. And all you got to do is see that parcel of land from the air and realize, oh, I can see things now that I couldn't see before. So the movie, ROTOR DR1, includes a segment on applications for drones. And we'll be talking about that here this evening, some of the things we're doing. So let's look at those applications. One of them is in the case of water limitations. Irrigation is very important to Nebraska agriculture, and it gives actually Nebraska a bit of a competitive advantage, right? All that groundwater, the Ogallala Aquifer. So are there things we can do to manage that resource very efficiently? Well, one of the technologies that's developed is variable rate irrigation. Very interesting. You apply a different amount of water at a different time at a different location across the field using a center pivot, for example. Very powerful. One of the challenges, though, is that this is a case where the technology has outpaced the ability to manage it. How do you make decisions about applying that water? That's a big question. How do you set those rates? Well, you could maybe guess. That's not very productive. That's probably not getting you anywhere. Always look and see what the neighbors are up to, right? That's helpful, but probably won't get you where you want to be. Water budget. Now you're starting to maybe apply some science. And, what's the precipitation look like? What are the projections? What's my soil moisture doing? What does it look like to the future? Let's make some decisions. Or we can go another step and maybe start putting in soil moisture sensors. Oh, now we're collecting maybe real-time data about the soil moisture, and we can start to make decisions based on that. But imagine that would take a lot of soil moisture sensors to really inform a variable rate irrigation system. So I'd like to suggest that we need a new view. And you probably know where I'm headed here, right? So now, shifting back again to the movie, the ROTOR DR1 movie, the focus is on multi-rotor unmanned aircraft, or drones. And that's something like what we see up here on the left side of the stage, over there. However, there are many types of drones, and let's take a look at some different types that we use in research. So this is called a Tempest. It has about an 11-foot wingspan. It's a fixed-wing aircraft, like an airplane. Looks a little different than your typical drone, doesn't it? And but it has a good payload, 10 to 15-pound payload. Easy 40-mile-per-hour cruise. This will go over 100 mile an hour if we really push the throttle to it. 1.5-hour flight duration. That's pretty good flight duration for drones. 2.3 horsepower motor. It's got all the controls of a typical airplane. And then we also have multi-rotors. Now, the other thing that the movie talks about is sensors, and you'll notice that in the movie. That it I guess didn't really talk about it, but the drones have little sensors on them that are looking around and seeing what's going on. And so these drones rely on the sensors to provide information, because just flying a drone doesn't really do much except it's fun. But we got to do more than have fun, right? We got to do something. We got to make use of that time and information that we can gather. So now let's look at some of the sensors that I'm using in the lab. In this case, what I've got up here is a MicaSense 5-band multispectral sensor. It's got 5 ports here on it, and that collects information as we're flying over a field. I also have on this image here a FLIR Tau 2 thermal sensor. And there's one up on the stage here also. That thermal sensor, we can fly over a field and measure the temperature of the field. So that's pretty incredible, to be flying 400 foot above ground level and just measure the temperature. And then we had to mount these sensors in the airplane. So in this case, we used a three-dimensional printed sensor mount. You can kind of see it in the fuselage here. So some students, enterprising students, a team got together and designed up this mount so we could put the sensors on it and put it in the plane, because you can't buy that stuff. It just wasn't available off the shelf. So here's a picture of it here. We've got the white here is the sensor mount that was printed on a 3D printer. And then these are the two sensors, the thermal and the multiband spectral. And then here it is here. Here's the aircraft. That's the canopy that we can open up and take this. Believe it or not, it fits in there. It slips right in and mounts in there. This is the propeller here. And that propeller actually folds back while the aircraft glides. And when the aircraft powers up, the propeller spins out and goes like a regular propeller. Because I know if you've been out in Nebraska weather, you're probably aware of how we can have thermals in the summer where we have air going up because it's hot. And so when we're flying over fields, the airplane will get into updrafts where it's going up and being pushed up by the air around it. Well, in that case, it doesn't really need very much power. In fact, the engine throttles down, the blades fold back, and it actually tries to stay down because we want to hold a constant altitude over the Earth's surface. And we program in that altitude. And then it tries to hold that as best it can. And then for every updraft, there's a downdraft. So when it flies into a downdraft, the motor spins up, propeller folds out, and then it starts flying and holding that altitude. Really interesting stuff. Very sophisticated when you think about what's going on in terms of control systems. Okay, so that's some of the technology, some of the equipment. Let's take a look at some of the projects. One is the, I kind of alluded to it earlier, the precision agriculture with variable rate irrigation. And here I'm going to show a launch of the Tempest. Here it goes. It's going to go pretty quick. That's a student there, Matt. He's got it, and I think he's going to try out for the football team. We'll see how far he can throw that plane. Actually, it has a winch that pulls it up as it goes. Whoops. Let me go back here. If I can get the cursor here to light up. There we go. Okay, here it goes. He lets go of it, the winch pulls it up, and then the motor starts up. And it flies away. And now what we do is we program in the complete mission that it flies. So that's a launch. Now here's a flyby, where it's just going to fly by us. It's completing one of its turns. We run back and forth across fields, and now it's flying down the field, down the line. And then there's a saying in aviation, takeoffs are optional, landings are mandatory. Right, so here we go. Gravity always takes effect here. And here it comes in for a landing. The flaps are down. And so this one just bellies in. We just bring it in and bingo. And it's carrying the sensors inside of it. So when we're flying this, we have to find areas. Usually we use pastures, for example, nearby the fields, cornfields or bean fields that we're flying. In this case, this was a nice area where we landed. Okay, so again, we're not out there just for fun, although it is fun. It's work. We have onboard sensors. And in this case, this was developed from that 5-band multispectral mica sense sensor. And what we have to do here is kind of complicated. You see how this has kind of a rugged edge to it? It's not smooth. Why is that? Well, what happens is we're limited to how high we can fly the aircraft. By the FAA, the regulatory threshold is 400 foot above ground level. So our sensors cannot see the whole field. We only see little parts of the field. So what we have to do is take a lot of pictures. And then all those pictures are brought together through a mosaicing process or a stitching process. Sometimes it's called stitching the images. And there's software that does that. So when we do that, we end up, we overfly the field. This is our field of interest right here. So we overfly the sides and the south and the north and so on. Then we can go in and we can cut that out. We do a clipping and just get what our area of interest is. But here with this we have a 16 centimeter resolution. And when we fly 160 acres, we're going to come back with about 22 gigabytes of data. So, you know, a megabyte, you think about a megabyte, a gigabyte is 1,000 megabytes. So we've got 22,000 megabytes from one 160 acre parcel. So that's a lot of data. That's when we're calling that big data. We have to deal with the big data. A huge amount of information in it. And this is a kind of a representation of the mica sense, the 5 bands, 1, 2, 3, 4, 5, that it's sensing. And then we also have the thermal. So here's a mosaic thermal image. It's a little bit coarser resolution because the thermal cameras always have coarser resolution. 44 megabits per 320 acres. And here's 2 center pivots that we imaged. Okay, another project is characterization of wetlands. And here I'll show you this firefly up here. This is an interesting one. We're kind of shifting to this now. It's a vertical takeoff, but it's also an airplane. So it kind of combines both. There it's taking off vertically. There's some power lines there. We were aware of them. We're safe that way. And so we've got a drone filming a drone flying. And you'll notice it's moving around quite a bit. It was a pretty windy day that day. We fly in virtually all conditions because we want to get that data. So we're out there in pretty windy, gusty conditions. So it's getting stabilized here. Starting to get its bearings. And there it goes. It has an initial drop. It's not as bad as it looks. And then away it flies. And it takes off like a, just you know, it's ready to go. So in terms of the wetland imaging, here's a approach is circles, lots of circles. And then this is a image of a screen image showing every one of these dots here is where a picture was taken. And we go around in circles and take a lot of pictures. And then assemble those pictures. So here's a wetland. And we want to create a virtual kind of image of that wetland. We want to measure the biomass, the vegetation in that wetland. So if we zoom in, we can start to see more resolution. And you can actually set a plane threshold and then compute the volume of biomass, of vegetation there. Another project here is invasive species. Maybe for the sprayer, for example. If you've got a wetland or something, a difficult environment to control those weeds in, why you can maybe use your sprayer to go, or you can go out this way, not too fun. Let's just take a quick look at this spray system flying. There we are getting it set up. The battery itself is bigger than most unmanned aircraft. We just got this last August, so we're starting to get a little bit familiar with it. When this thing is flying, I steer clear. I stand back. And there you can kind of see the sprayer's on. This is about as big as you can get for an unmanned aircraft. It weighs just under 55 pounds when it's loaded up with water or pesticide, herbicide, whatever you might put in it. Okay. This one is a measurement of water quality. And real quick video here. This is another one. This is an octocopter. It's called a DroidWorks. And in this case, this student is looking to measure lake water quality. And so that disc that he's carrying there is called a Secchi disc. And scientists use that to take measurements of lake water quality, how clear the water is, for example. So this is Galen. He's flying it. He's going to take it out. And we're starting to figure out, what do we need to do? We're going to he's mounting a video recorder on the unmanned aircraft. And so where that goes in the water and how deep it goes before you start to lose resolution gives you a Secchi reading. And that Secchi reading then is converted to water quality. And the nice thing about this is a typical way of doing this is getting in a boat and going out and taking all these readings. But with the unmanned aircraft, you can go to the same location every time that you want to do this, or set of locations, and do the readings at the same location, because repeatability is very important to hit that exact location. So real quickly, drones in the movie have artificial intelligence, and they're able to fly in a safe manner because of that artificial intelligence. We're not quite there with our drones yet, but yet safety is important. And I just want to wrap up with this, and that we need to be aware there are other low-altitude piloted aircraft. And these, for example, aerial applicator aircraft can range in values up to $1.5 million. They fly pretty fast, 150, 180 mile an hour. And believe it or not, they can be difficult to see. They can sneak up on you. And might ask you, well, what can possibly happen? Well, here's a side view, and I want you to notice that canopy there where the pilot sits, and that's the result of hitting a bird. The pilot survived. It looks pretty bad, but usually aerial applicators will wear helmets with face shields. They almost look like an astronaut or something. And so that was very helpful in this case. But imagine if that was an unmanned aircraft with batteries and carbon fiber and stuff. So one of the projects I'm working on is I'm calling a safety beacon. So here this beacon would be deployed on top of a vehicle that's the ground control station is located at. Those are Wayland strobes. They're very bright, and any low-flying aircraft in the area will see them and realize that there's unmanned aircraft flight operations in the area. Because we know you just can't put a bright enough light on an unmanned aircraft. It's not possible. It's been tried. A lot of people have tried it. You can't see it very well. These are extremely bright. In fact, these are like on ambulances, for example, called M9s. Okay, also in safety is regulations. The Part 107 Remote Pilot Certificate is important. There's all kinds of things you need to learn. This is airspace. It's very complex, our airspace, but that's what leads to safety. This is a sectional map. You kind of need to learn how to read these to get your certificate. And sectionals, though, are representing three-dimensional space on a two-dimensional object, your map, for example. Okay, I kind of want to wrap up here. In the movie, the drones, the drones play a prominent role, but really, in the movie, the message is about people and humanity. And so for us, we're asking the question, can we produce food, fuel, and fiber in a more efficient, sustainable manner using aerial robotic technologies. So they're just a tool, and what we're really after is sustainability. So I think with that, I will go ahead and wrap up. I would like to thank, again, everybody that has brought this about. It's an awesome opportunity and really neat stuff, science on screen. So let's see here. I am going to go ahead and bring up the slide. Here we go. Okay, here you go.
Thank you, Wayne. So we have a couple other guests to introduce here, and one is Don Maston, and he is a pilot, EMT, certified law officer, and small business owner. His work has included fluid measurement devices, alternative fuels, center pivots, subsurface drip irrigation, and flow meters. He brought true thermal imaging to high plains with the Air Scout program. Don is past president of the Central Plains Irrigation Association and a board member. Thanks for coming today, Don, for our Q&A session. And Tracy O'Neill, faculty member at Western Nebraska Community College in Scottsbluff. He teaches human anatomy and physiology. Tracy began flying small unmanned aircraft 5 years ago for projects including construction and site assessment, feedlot evaluation of feeding practices, and working with the Gering Fire Department to film training procedures. His goal is to use his drones locally to help or assist in community needs. Thanks, Tracy. So what we're going to do is take a few minutes to talk a little bit about some of the reasons why they got involved in drones, UAVs in general. And Don, sorry about that. Don has a film clip that I'm somehow going to.
Yeah, what we're going to see here. I'm a business person, so I have a commercial component to what I do with drones, and so it works in correlation with our aerial imaging that we use from a certified aircraft, and so it's an amateur production. Forgive the amateurish part of it, but it shows you exactly how our system works, and you'll kind of see as it goes. It's pretty automated, and it's a real tool for the farmer for scouting.
Yep. Okay.
First, we power up the machine.
So we're going to turn on the drone.
Yep, hold it until it chirps at you. Hold the power button down.
Okay, so the drone's on. And as we turn on the drone, we'll get a live picture on the left side of the screen there, and I'll show you that when we get that.
We just plug the phone in. And it automatically launches the Air Scout app.
Now what we need to do is we need to match the iPad to the drone, so he'll give me a drone code here. So I'm going to hit here, connect to drone.
Yep, I hit connect to drone on the cell phone.
GPS 3D lock.
It connects, and then I hit connect to server. And that gives me a drone ID. Then I let him know the drone ID, which is 642. And he puts that in on the iPad.
So 642 on the iPad. So it enters in on the screen, and then we're going to connect to drone. So now we have a live picture from the drone, as well as a picture of our field on the iPad. So now I'm going to go to this field that we're standing in. I'm going to mark a position in the field by touching the map. So I want to go to this spot we've identified right here as being something we want to look at. So I mark that, and it puts a red flag on the field where I want to go to. So now we have the drone is ready to go. We've got the field marked, and so I'm going to arm the drone.
Waypoints received.
Okay, so now the drone is armed and ready to roll. So I'm going to hit takeoff. It's going to launch, and then we'll hit waypoint. And it'll go to the intended destination.
Waypoints received.
So now it's going to go to the pre-selected waypoint.
Hey, it's on its way. Start filming. All right.
So you can see the drone is headed to its selected destination, and then when it gets there, it'll hover and we'll take our pictures, and then we'll hit return, and it'll come back here and it should land in the same spot it took off from. Now at this point I've got what I want to take my pictures of, and I hit save picture on my controller. So it'll take that picture and save it. I see another picture I want, I'm going to save it. At this point we can either pick another location closer to it or somewhere else in the field. I'll go ahead and bring it back a little bit closer to us and let it hover. So I'm going to select on my screen a new waypoint, and I'm going to select waypoint on my iPad, and it should come back to that new location and hover as well. So we can see now that it's actually moving back towards us to the new location, and eventually here you'll see it come into view. Okay, so it continues to hover there. I'm going to take a couple more pictures. Now I'm going to hit return to land, and it's going to come back here to where we're at. Now if you can see that gain in elevation, it actually travels at a higher elevation than we take the pictures to clear obstructions. It'll actually come and hover right above us, and I'll command it to land. It should land in the same spot it took off from. You should see it coming into view. It's going to get to our location and hover. And I'm going to command it to land. So that's just a quick example of how we've made this available to our growers to do crop scouting, and we've tried to take all the guesswork out of it that we can. The steps that we use to launch that have actually been streamlined even more, so you don't have all those steps. It arms automatically and it takes the waypoints automatically instead of having to make a separate move. So that's what we're doing to make it more productive for the farmer.
Thanks for sharing that, Don. It didn't blow up at the end, right, where it cut out? No. I got a couple questions to ask our panelists, and then I'm not going to spend a lot of time talking, but I want to give you all a chance to ask questions that you might have about drones or their use. you know, Wayne started talking a little bit about at the end of the film, or at the end of his presentation regarding safety, and then you got into some of the requirements. I guess just put this up for all the panelists, just maybe if you could describe a little bit about the legal requirements to allow you to fly these either for commercial uses or research, and what differences there might be between the two.
Okay. Well, the requirements at the federal level are what is called the Part 107 Remote Pilot Certificate. And you achieve that by taking an exam. And the exams are administered usually at airports like Lincoln Airport, Silverhawk Aviation. They're pretty tightly controlled exam settings where it's a room that you go into, and it's a pretty sterile room and a computer, and you kind of got to know your stuff in order to pass the exam. They're generally multiple choice type exams, but the FAA is pretty good about putting in trick questions and things that look like it's right, but it's really wrong. So that would be the minimum requirement. There are no state requirements. There is some state legislation that's before the legislature at this point in time, but it would not increase any sort of requirements to fly. But you'd want to be aware of any rules and regulations, both the federal and state and local level. The sprayer, however, is a little different. That does require a second pilot certificate, which is a aerial applicator certificate. So a spray pilot certificate would be necessary to fly that and apply herbicide or pesticide or something like that, other than water. We're just using water right now. So that's a little bit more, but I anticipate FAA is going to modify their standing on that also, because the pressure is just going to mount too much to allow them, not to be used. Because the cost of entry into a Part 137 pilot aerial applicator pilot certificate is, if you've already got a private pilot certificate and you need to get your commercial and your spray pilot, is about, best I've seen is about $18,000. So usually people that go that far are going to want to be flying aircraft and the big things, the big ones.
And just in relation to that, the kicker here is if you're making money with it. So if you sell a picture off that drone, you have to be a commercial pilot. However, the way we do it, we actually sell the drone to the farmer. It's about $600 for that package, and includes everything to run it. You have to provide an iPad, and that way he can fly as much as he wants and take all the pictures he wants, because it's his drone, his property. But if I sell one picture off of that, then I have to have the Part 107 commercial license to do that.
That's really interesting.
One thing that's also interesting about this from the regulatory point of view is that you don't have to prove you know how to fly these things. In any other pilot certificate, you need to show you can fly them. Fly an airplane, which is probably a good idea. These are the one aviation area where you don't have to prove proficiency in flying. So there's been, I think, more than a handful of folks that have bought one of these and gone out and, uh-oh.
We talked about that a little bit earlier, that just because you have a license doesn't mean you can fly it. And that's very true. I guess I've got one more question before I'm going to hand it off to the audience and have a bit of interaction here. Is, I guess from each of you, what kind of opportunities did you see in kind of inspiring your decision to kind of pursue this as a course of action, whether it's for commercial use or research pursuits?
Well, I can only speak for myself because as I said, I'm a bit humbled by the experience that the two gentlemen here have. But I started out like a lot of people. It was fun, okay? And it still is fun. I haven't lost that. However, I've graduated up to larger ones until I've come up to this one over here on my right here, on your left here, which is primarily an industrial drone. It's designed to fly in all kinds of weather, temperatures below zero, and it allows you to put different configurations for cameras. So for example, in this one, I have one camera on the bottom of it, That's a zoom. You can put 2 on it and actually see the images transmitted at the same time on the monitor. Or you can plant one on I'd rather put one on top of the drone. So I guess what my long-term goals are really going to be is, in the past I've done filming for weddings and all that as doing it free. I mean, it was something that was fun. But ultimately what I want to be involved with is a lot of things locally, for example, in fire and rescue, because that's what this is designed for. Again, like I said, it'll fly in inclement weather and all that. So that's really where I've kind of, I wouldn't say morphed, but I've kind of moved into that field. None of this is really anything that I'm an expertise on. I've gone through the 107, and so it's a learning curve. But I will certainly say I'm never qualified to actually fly the thing with me in it, any of these here. But you're absolutely right. There's so many odd little loopholes in the law. And so, again, my long-term goal is to do things here locally and try to help with the community that way.
And of course, you've seen the demonstration here. We actually have in the Air Scout program, we actually take thermal images of the field from an aircraft. And so we're using it as a scouting device. You can get all the information you want, and if you don't go out and ground truth it, you're not going to make very good decisions. And so we entered the drone program to work in conjunction with that aerial imaging, so that the grower, the operator, could go out there without having to walk into 10-foot tall corn in late August when it's hot. He can actually fly the drone out there and do his ground truthing from that. So that's kind of our angle as far as the drones are going.
And for me, I think the way I'd answer this question is where I started my presentation is the projections are that agriculture is going to be 70% of this drone market. So that tells me, since I'm in the biological systems engineering department that used to be known as agricultural engineering before the name was changed. So since I'm in that department, let's say ag engineering, this is something I better be getting familiar with. So for me, it was an opportunity to see and learn about new technologies that can help improve production, improve efficiency, and sustainability of agriculture.
Well, thanks for that. I'd like to hear from the audience. Any questions you have? We have quite an array of equipment here on the front of the stage. I believe most of it, with the exception of that black drone on the end, is Tracy's or is Wayne's. So if you have any question about the equipment or anything else that we haven't thought of, raise your hand.
Raise
We've got
your hand,
a
I'll
mic
come get the mic to you.
Tough crowd this evening. I know some of the folks in the audience. I'll point you out.
And maybe to prime the pump. Oh, here's a question.
What's the cost of, for instance, your industrial one on the end? What's the cost of
This one here?
Imaging camera?
It's limitless. No, I'm sorry. There's different levels of this brand. Now these are DJIs, which are these through here. The Matrice 210 RTK, and this RTK, they abbreviate that as real-time kinematics, but it's for localization of the drone and some variety of other reasons. But the drone itself, the cost of that single drone is $15,000. And the cameras vary. The batteries, I've got extra and all that. But the camera itself, which is it's a 30 optical zoom and a 6 digital, does 20 megapixel pictures on that. That in itself is around $9,000. So if you were to, which I cannot afford at this time, but what I would love to equip it is a thermal camera that you could put in the front there. So that would allow you to go to thermal back and forth to the other images. And those are incredibly pricey. So, maybe when I grow up a little bit more here, I can afford another one. Beg your pardon? 13. Yeah, the XTs. Well, I know they come in two different levels. So, but at any rate, so the con to that is the cost, But the way I look at it, I've had an opportunity to learn a lot of neat and cool skills with this, and if I can give this back to helping find somebody, if I can give this back to doing something that way, to me, at the stage that I'm at in my life, that's a positive thing. But anyway, hopefully that answers your question there.
So the guy in the
The thermal imaging program from the aircraft is $7.50 an acre for the season, so we do 12 images for $7.50 an acre. And our time through the season to get the best information at the best time. The drone itself is $600. And we do that, it's a simple drone. We remove all of the guidance and the electronics and replace it with our own for a couple of reasons. One, we enhance the GPS. We actually put two GPSs in there, and we get sub-centimeter accuracy. And then the second thing is I was talking to someone earlier about this, a drone, when it loses signal or when something goes wrong, it goes home. And so home is China, right? So I saw an interesting article last week on Yahoo, and it said 20 to 30% of the drones that were received for Christmas are already missing. Because they're headed to China. So we remove that. So ours, when you launch it, that becomes a reprogrammed home. So if something goes wrong with that drone, it's going to come back to that spot. And we've demonstrated that with one of our units. And it came back to us without a signal, and it hovered until the battery went dead and just slowly settled to the ground. But about $600, and that includes the smartphone that we attach to it for doing the photographs. And it's also run off the cloud. It's not run off of Wi-Fi. So you can run that thing from anywhere in the world. I mean, I could send one to Lincoln and I could fly it from here as long as I have internet. And we do that because of there's so many things that'll break that signal and make you lose it. So we've done a few things that are a little bit different.
You run that through the program to do the imaging is like 7.5 acres.
That's what the aircraft base, that's for the thermal image from the aircraft. This works in conjunction with those images. If you saw that image on the iPad, that was actually a thermal image of that field. I saw the area that I wanted to look at, I marked it. So if you see a problem in the field where there's bugs or lack of nitrogen or fungus, you can fly to that point and identify. That's what you're ground truthing with, and that's how it works. It won't work with any other program, particularly. We set it up for the Air Scout program.
Okay, we have another question.
Tracy, can you tell us about the white one capabilities and the price?
Well, the white one, that one's, well, that's not mine, the white one here. But when you get into the Phantom Pro 4, and I may be off a little bit, but those are, when you get the complete package with that, is that yours, isn't it? Yeah, I know that on the website, when you get everything, and of course not talking about extra batteries, you look at around 14, about 1,400. The whole issue with all of these, and I like with the one that I have, the batteries are the huge major issue, and parts of it at least. You never have enough power, right? No, but at any rate, I believe it's somewhere around there. And again, the only additional cost to these is that you have to provide either a smartphone or you have to provide a tablet. I believe that's what it's worth, I believe.
So we're getting pretty close to time here when we need to be starting the movie. Is there another burning question in the audience? Maybe from this other side of the room? Anyone? No?
I can maybe follow up on that while someone's thinking of a question here. Following up on the idea of the batteries. There's been more than one time we've been coming in from the field after doing some research, and we're driving and riding in the truck, and someone invariably says, "Well, right now I think the only people making money on this stuff are the battery people." Batteries. There's batteries everywhere. There's batteries in the transmitters, batteries in the aircraft, batteries in to power the sensors. It's just, and you got to make sure they're all charged up and ready to go. And battery, we actually have a battery log that we keep track of our batteries with. As far as when we charge them, they're computerized. We have a computerized charger, and it tells us all about how it charged that battery. And we write all that down, and each battery is labeled so we know what it is, because we got to manage those and make sure that we don't have one that's failing prematurely, because you can't tell by looking at it. And we want to know if a battery is going to be failing on us so we don't use it again. So batteries, they're lithium polymer batteries. They're a pretty intense source of energy. If you've ever seen one go up or self-destruct, it's pretty impressive when they burn. You can't hardly put the fire out because of the reactions that are taking place. But in the movie, they've got something even better. So you might find that interesting in the movie. Oh, wait. There's a question.
Okay, last question.
Okay, you say that a lot of these you use a cell phone or a tablet. How about if you're in a rural area that is not covered in cell phone range?
On our particular model, we use the data side, which is usually you can get a text, and there's places that you can't. But versus like talking, a voiceover, it takes a lot more signal. And so we're going through the data side, so you get a lot more range that way. But there are some issues with that. We do make a manual mode for those where we go back to the transmitter that's in the controller. And you have to be a little bit more careful with it because it can get out of range that way. But we plan for that on the backside if we can. But most places here in the high plains, we can find a signal pretty decent.
One other thing, for example, on this particular, they call it a ground bridge like technology. This one's a closed system. The monitor and all that connect, I mean, it doesn't require Wi-Fi in this instance to fly it. So you get your own monitor with this, a remote and all that, so you're pretty independent within that system. One of the Phantoms that I have uses Wi-Fi. This one has the capacity, although I would never do this, and I have no idea that I'd ever see it again, but supposedly will go about 4 miles. I don't know if it ever come back, but at any rate, so there's a little bit different, you know, like what you say with the Wi-Fi. That's the one thing that is unique to me that I like, is that it doesn't actually use that direct function. So again, you pay for it, but it comes with its own, quote, tablet and everything else in it. So I think there's, you know, a lot of options on that.
I'm going to make one more quick statement. For you young people here, this is the future. I mean, this is a wide open field that's going to get better and better and more as you go forward. If you have an interest in these things, get into them now. Get the small ones, get the cheap ones, learn how to run them. Take your 107 test if you can. The future's right here. And I'll guarantee if you get excited about this and get into it, it's going to be a career.
Please thank our panelists.